All right, guys, in this video, I'm going to talk to you about Newton's first law. But first, let me get a couple definitions. Mass is the amount of matter in an object, and I'm sure you already knew that. But since I'm going to be talking to you about something called inertial mass, I figured this was important to go ahead and define again. And the units, as you know, would be kilograms. Inertia, however, is an object's tendency to either remain stationary or remain at a constant speed in the same direction. In other words, this is an object's resistance to acceleration. If you think about what this sentence is saying, it's basically saying if we were to look at acceleration being a change in velocity over a duration of time, well, we're talking about a zero velocity, which is not changing, or we're saying a constant speed in one direction, which is saying a constant, unchanging velocity. So this applies to an object that is either at rest or is moving, but moving with a constant velocity. That's what inertial is, this object's resistance to a change in velocity or acceleration. I'm also going to talk to you about something called a net external force. So this is very early in the dynamics unit. A net external force is basically an unbalanced force that will lead to a change in velocity over time, that will lead to an acceleration. Let's go ahead and look at your College Board equation sheet. I want to talk to you about this equation here that we will use for the remainder really of the course and certainly use throughout this particular unit. What this is saying is that acceleration, which is a vector quantity, is equal to the sum of the forces, which you know a force is a vector quantity, divided by the mass. That's what this is saying here. Acceleration is the sum of the forces, or net force, over the mass. So summing the forces is another way of calculating the net force. And remember, it is a net external force that can lead to an object's change in state of motion or an acceleration. Okay, so when you sum the forces here, what you're basically going to do is simply take all the forces acting in a direction and you're going to add them all up. And if you get anything other than 0 newtons, that means you have a net external force. That's why I keep saying like an unbalanced force. So if you get anything other than 0 newtons, you're going to have some sort of acceleration for that object. Okay, let's look at our proportionalities here. So the acceleration from this equation is proportional to the inverse of mass. In other words, if mass goes up, acceleration will go down. And if mass were doubled, acceleration would be reduced by 1/2. Let's look at an example here. Here we have a man pushing on a crate in one image, and in the other image, the man is pushing on a crate garbage can system, so a composite object, okay? Which one has more mass? Well, clearly the crate with the trash can on top of it has greater mass and thus greater inertia, a greater resistance to a change in state of motion. All right, so if the man applies the same force in both images, which object will have a greater acceleration? That would be the crate, because the crate has less mass, and we know that the force applied is going to remain constant for both. So if the force goes up, the acceleration goes up for a given object. And if the mass is doubled or goes up, then the acceleration will go down. So the crate will experience a greater acceleration for the simple fact that if force remains the same, then it has a smaller mass, and Therefore, we will see a greater acceleration because acceleration is inversely proportional to mass as long as the force remains constant. All right, so let's define inertial mass. An object with more mass is going to have this greater tendency to resist changes in state of motion, which I've already defined as an acceleration, a change in velocity over change in time. So the greater the mass, the greater its tendency to maintain its current state of motion. Okay, so this is basically the definition of Newton's first law, is that an object's going to maintain this constant state of motion, this constant velocity, unless there is a net external force, unless the forces, when they are summed, give a value other than 0 newtons, then the object's going to maintain its current state of motion. Okay, so if an object's moving to the right at 5 meters per second and there are no forces, net external forces on that object, it will just simply continue moving to the right at 5 meters per second. All right, so I have a question here that I would like to pose for you all, and that is, could you design an experiment to calculate the inertial mass of an object given what we've discussed in this video so far? All right, so we're going to be using this equation straight off of your equation sheet, and so you are asked to calculate the inertial mass. So you're going to need to find a way to calculate the forces, the net forces, and the acceleration. And from the previous unit, you already know a number of ways to calculate acceleration. However, for forces, if we haven't already started some of our dynamics lab, you could use a force sensor, you could use a spring scale, and there's a multitude of ways to experimentally calculate force. So let's take a look at this PHET simulation here. I am going to click on forces for the vector, summing of forces, values. I'm purposefully skipping over mass because that's what we're trying to calculate. Clicking on speed and also acceleration. We're in a frictionless environment, and now the man will apply a 100 Newton force, and it will cause this object to accelerate. Let me go ahead and do that right now. So we see the object accelerates from rest, reaching a constant acceleration of 2 meters per second per second. Of course, the speed is increasing because the object is accelerating. Now I'm going to pause this, and let's go ahead and do our calculation. What's our sum of forces? Well, there's one force acting to the right, and that would be the force of the man on the crate, and that force is going to be in magnitude 100 newtons. Okay, and the acceleration we were given right here from this meter on your screen to be 2 meters per second per second. That means that we can plug in our values and calculate the mass of the crate to be 50 kilograms. All right, pretty cool. Remember that number, because now I want to swap out my crate for something a little more massive here. And I want to apply the same 100 Newton force to this object. Here we go. 100 Newton force, and the object will now accelerate from rest and begin moving to the right at a constant acceleration of 0.5 meters per second per second. The speed is increasing, but the object is accelerating because there is a net external force being applied. The 100 Newton force of the man on the refrigerator. Now I'm going to pause it, and I want to perform the same calculation as we did with the crate, and we get the fact that this, when we take the 100 newtons, which is our net force, and divide it by the acceleration, we are calculating the inertial mass, and we calculate that to be 200 kilograms. All right, now I'm going to click on masses, and you will see that the refrigerator weighs, or has a mass, excuse me, of 200 kilograms, and the crates down here, recall we calculated 50 kilograms for the crate, and so this is how you would go about calculating the inertial mass. Now, two other things I want to show you before I wrap this up. One would be to look at the fact that the units here, kilograms times meters per second squared, which are the base SI units for a Newton, divided by meters per second squared. What do we get? We're left with kilograms, which are the base SI unit, which is the base SI unit for mass. Now, one more thing I'm going to unpause this. I'm going to click off of the forces here. Actually, no, I'm not. I am going to stop this man right now. He will no longer apply a net external force. Here we go. Man leaves, man stops. What do we see happening here? This object keeps on going, and it keeps on going at a constant speed of 21.5 meters per second. It will not change its state of motion. It will keep doing this until it is acted upon by a net external force, because this object has inertia and therefore has a resistance to a change in its state of motion. Okay? All right, guys. So, wrapping this up, in this video, we've talked about inertial mass, we've talked about inertia, we've talked about Newton's first law, and the relationship between a net external force and an object's mass and its acceleration. And I'll see you guys in class.